So we're going to do solving absolute value again. This is section 6.6, examples 2 and 3. So these are solving absolute value inequalities again. It's just that these are going to be a little bit harder because they're not just going to be the absolute value of x or y. There's going to be something inside that absolute value. So, for example, we might have the absolute value of x plus 2 is greater than 1. So if I have the absolute value of x plus 2 is greater than 1, I can't just go directly to my answer. I have to, like we always do with absolute value, make two, this time inequalities, instead of equations. So I'm going to take x plus 2 and 1 and x plus 2 and negative 1, just like we split up the equations when we did absolute value equations. If I have a greater than sign, I'm going to go greater than 1, and then I have to change the other one to less than negative 1. Okay, so, oops, get the highlighter here. This greater than sign gives me the positive 1 I write as a greater than inequality, and when I do the negative, I do as a less than inequality. Okay, we'll do a few of these because we'll do a lot of these together because these get a little tricky as to how you set them up. All right, so now it's all about solving these inequalities. X plus 2 is greater than 1. I subtract 2 from both sides of this inequality, and I get x greater than negative 1. And I subtract 2 from the other inequalities, and I get x less than negative 3. And these ones become an OR. So that's the other piece that goes together with the greater than, the two inequalities, and they become an OR. So on my number line, I will graph the negative 1. This one has an open circle. The negative 3. There's the 0 here. Let me redo my number line. I made that. Sorry. Let me do this. There's my 0. I got the negative 1 with an open circle, the negative 3 with an open circle, and whenever we have an OR with our compound inequalities, the ORs we always shaded the outsides. Okay? No matter what. I mean, you'll find when you do Algebra 3, we'll have some exceptions. But in Algebra 1, we won't have any exceptions to that. It's going to be no matter what. Okay? Then we have absolute value inequalities that are less thans. So I might have, grab the example I want to use. I guess I don't see the example I want to use. So we'll have absolute value of 4x minus 5 is less than or equal to 9. Okay, so this one has the inequality pointing the other direction. So let's see what goes with that. Okay, so with the less thans, I'm still going to turn them into two inequalities to solve. 4x minus 5 and 9, and 4x minus 5 and negative 9. But when I have the less thans, I'm going to do the less than, or the less than or equal to, with the positive number, and I switch it to the greater than or equal to with the negative number. Oops. Okay. Now we're going to solve these two inequalities. I'll add 5, and I'll get 4x is less than or equal to 14. Divide both sides by 4, and I get 4x is less than or equal to 3.5. I'll do the same with the other inequality. Add 5, and I get 4x greater than or equal to negative 4. Divide both sides by 4, and I get x greater than or equal to negative 1. And these become an and. I write this equation 2 times, or write this inequality 2 times. Oh, thank you, Carrie. My bad. There we go. There we go. All right. So now my number line is going to have, I'll put the 0 there. I'm going to put the negative 1. This time the negative 1 has a closed circle. And I'll put the 3.5 here with a closed circle. And when I have the less thans, I have an and. When I do ands, I shade in between. The ors are shaded on the outside, the ands are shaded on the insides. Okay, so let's see how many of these we can get done. Yes, ma'am? I guess if only if it's an emergency. No. I'm not kidding. You came in late to class. You don't get to go. You don't get to leave when you come in late to class. Shh. Okay. All right. First problem we got to do is d plus 4, absolute value of that, is greater than or equal to 3. So when we're doing a greater than or equal to, that was the first example we did. We do greater thans or greater than equal to. We split it up into two inequalities to solve. D plus 4 greater than or equal to 3, and d plus 4 less than or equal to negative 3. We change 3 and negative 3, greater than for the positive one, less than for the negative one. Then we solve these two inequalities. I'll subtract 4, and I get d greater than or equal to negative 1. Subtract 4, d less than or equal to negative 7.